something that I've realised in turning these spheres is that the way I'm doing it is got advantages. The 4 divisions will give us this one. If I'm crossing both of those points in the rotation, I'm on an axis that's at 90 degrees to the equator. I've got the other ones are underneath this, so it's a good way of centering this properly in my between sphere centers, cup centers. So that's one thing. So I've just turned the points off, and I'm gonna put a line through there first of all. Right, and then get my ruler back. We're spot on again. Now I'm going to divide that line up into 4. We know that one should cross there, it does. Make sure we end up back on there, yep. So, the axis we haven't done yet is that one there. But let's just get it centred and see where we stand. It's easier than guessing. One, 2, 3, 4. Tiny touch. There we go. 1, 2, 3, 4. Right, we're passing through all 4. And what that's done now, I've divided the top, this top into 4. So I've divided that sphere up into 8. 6 points, 6 vertices, and 8 whatever they are, sides. So the 6 vertices are going to be the points we turn from to get to the sides of a cube and a tetrahedron. No, the tetrahedron is a mixture. We're going to find the central points of those faces now in the next part, and that will give us 8 points, which will be the faces of the octahedron, and the combination of the points will give us the positions of the tetrahedron. So we'll mark up one of those shapes on this in a minute. Right, I've got a small compass, and I'm going to guess, what guess you say? Yeah, guess a little bit further than the centre. I want to say about there, and come in from each of the 3 vertices around it, around one of the faces, and you can, somewhere in the centre of there. So I'm way too far out at the minute. So somewhere about there. A little bit too far still, just there. Pretty sure that's going to be it. get a pen and mark it. I've just lost my lid, but when you've done that 8 times, so we're going straight through it, so we do it for that one. I've still a little, got to open it out a little bit. That's it. When we've done that for all 8, we'll have the 6 sides needed for some of the shapes and the 8 sides. I'll mark it up in different colours needed for some of the other shapes. So that's our sphere marking. I'll come back when that's complete. Right, I went ahead and marked up all of those 8 points, and I ran away with myself and I marked up the markings to turn the cube, and that is a circle from each of the 6 cardinal points that goes through these new halfways, and so everyone has got a circle around it that goes through those points. And to turn the cube, it'll be between step centres, because it doesn't matter about messing this end up. I'll put it between step centres, turn one side down to a small tenon, like a 10mm tenon or something like that. Then I can put that side in a collet chuck and turn the other side, which will now be this end, flat. And I'll do that for 3 of the faces. So every opposite face will be flat, and on one side, one opposite face, I'll have a tenon. Then to turn away the tenons, you could saw them off and sand it, but I'll probably make a faceplate, stick it with double-sided tape to a faceplate, and turn away the other side, so we'll end up with the cube. We know that all those points touch the edges of the sphere, so we'll end up a cube that fits in the sphere. On the subject of the sphere, right, I've got one here. When I measured this, it's not really a problem, but it's a thing, is I measured the inside of half of the shell, and it fits in there perfectly, 58mm. It's a 60mm shell, but you can't close it on a sphere because the centre of this side is here and it narrows. But when it's the cube, it will go in there, obviously, so I'm going to take the gamble that I don't need to make these spheres any smaller, that the shapes will fit inside this sphere. And maybe on the dodecahedron and the icosahedron I might make them a little bit smaller, but we'll deal with that when we come to it. Now the other thing at this point, we can mark this out for the cube. We can also mark it out, and the cube is done by turning between these points. If we turn between those points and did the same thing, like the opposite pairs of crosses, we end up with an octahedron using the same method. You know, turn one side to a tenon, turn the other side flat, reverse it, turn the other side flat. You get it. But here's how we get the tetrahedron. You know, if this was a cube and we were making a 3-winged bowl, we mount 2 sides of the cube opposite each other, and we make sure that the tips of the cube, which are going to be these lines, obviously, well, not obviously, but there will be these points, and when they all pass through the same axis, there we go, those ones will turn through the same axis, and from that centre that's inside there to these three back points is our tetrahedron. So the tetrahedron will be turning away this face, and it's gonna get awkward. This I'm gonna have to make a little three-sided chuck, I think, to hold this as we get down to it. Turn away the back, then move each of those three faces here to this centre, and turning away the opposite face, like the same thing the opposite way, if you see what I mean, and we'll end up with our tetrahedron. So out of that markup we've got our cube, octahedron, tetrahedron. Okay, so next thing I'll do, I'll come back when I've turned a bit of this cube. Thanks for watching.